Verify the function satisfies the three hypotheses of Rolle's theorem on the given interval. Then find all numbers C that satisfy the conclusion of Rolle's theorem. So number one, we can say that f is a polynomial and therefore it must be continuous on the closed interval from -1 to 3. The second, f is a polynomial and therefore it must be differentiable on the open interval from 1 to 3. -1 to 3. And number 3, if we evaluate f of -1, we get 11. And if we evaluate f of 3, we also get 11, looking at the two endpoints. Let's look at the endpoints of that closed interval. F evaluated at -1 is 11, and the other endpoint, f evaluated at 3, is also 11. So we have verified that the function satisfies the three hypotheses of Rolle's theorem on the given interval. Up next, we want to find all values of C that satisfy the conclusion of Rolle's theorem. So let's find the derivative first. F prime of x is 4x minus 4. And we want to set Next, we want to find the C value that makes the derivative 0. So we're just going to replace the x with C and solve our equation. 4c equals 4, c is equal to 1. And since c equals 1 is in the open interval from -1 to 3, it satisfies Rolle's theorem. Graphically, what we're looking at with Rolle's theorem in the previous example is we have a polynomial, so we know in this case it is continuous on the closed interval from -1 to 3. We also know that it is differentiable on the open interval from -1 to 3. We also have a point where the y values of the function are the same. In this case, the y values are both 11. So if that's true, then there must be a point C between -1 and 3 where the slope of the tangent is 0. And we found that that happens at a C value of 1. So we can see when C is 1, the slope of the tangent line is 0.